So now that we know how to do an empirical formula calculation, what if the numbers don't come out to be whole numbers? So that's what I'm going to show you in this example. I have 25.9% nitrogen and 74.1% oxygen. What is the empirical formula? So I'm going to take 25.9 grams of nitrogen and 74.1 grams of oxygen. So this is going to be no different than the previous problem I showed you. Okay, it's just going to look different in terms of the numbers that you get. So you get 1.85 moles of nitrogen, and you get 4.63 moles of oxygen. So again, you divide it by the smallest number. So the smallest number here is 1.85. So that becomes 1, but then this becomes 2.5. Okay, so I can't round this down to 2, and I can't round it up to 3. So 2.5 is legitimately the relationship to 1 to 2.5. So I could put nitrogen, oxygen, 2.5, and that would be an okay way of writing that formula. But again, because we want whole numbers, what I'm going to have to do here is multiply by a number in order to get it to a whole number. So if I multiply 2.5 times 2, that's going to get me to 5. But please note that whatever you do to this, you have to do to the other one as well. So that means my final formula is N2O5. So if you have something like that, you multiply by a number above that. So again, most of the numbers I'm going to give you are going to come out to be whole numbers, but if you have something like that, you might want to use that. So in this next problem, it will come out to be not a good number. So see if you could try this one on your own and then come back to the video. So again, this comes out to be a 1.5 and a 2.5, so you have to multiply everything by 2. So you end up with an empirical formula C3O2H5. And again, we're going to see some of this data from something called a mass spectrometer further on in our course. So that's why I kind of want to show you that technique. So the last thing I want to mention is, well, we have empirical formulas, but we started this whole lecture talking about molecular formulas. Well, molecular formulas are whole number multiples of this empirical formula. So an additional problem that you're going to be asked to do is, if I give you molar mass of a molecular formula, can you tell me what the factor is essentially of what it's multiplied by? So if I have an empirical formula of CH5N, and the molar mass of the molecular formula is 62 grams per mole, what is the molecular formula? Well, you know the empirical formula is this. So what I could do is I could add up. I got 12 grams for carbon. I have 5 grams essentially because I have 5 hydrogens. And then I got 14 grams, which is nitrogen. So I have a molar mass of 31 grams per mole. So what I'm going to do with these types of calculations is I'm going to do the molar mass of the molecular formula over the molar mass of the empirical formula. And that should come out to be a whole number. So in this case, it is 62 grams per mole over 31 grams per mole. So every 1 mole is that. So 62 over 31, of course, becomes 2. So the molecular formula is going to be 2 times the empirical formula. So it's going to be C2H10N2. Okay. So I have to give you this bit of information. You can't find it any other place, but that's going to be how you do it. So to summarize this last problem, here is my empirical formula. Again, it's the empirical formula of glucose. It's also formaldehyde. If the molecular formula is all the way up to 180, what does that molecular formula happen to be? So again, you start with adding everything up. So I have 12 grams plus 2 plus 16 gives me a total of 30 grams per mole for my molar mass of my empirical formula. And I got 180. Now this case, you do put the bigger number over the smaller number, and it should come out to be a whole number. If it isn't, it's just because of rounding issues. So this becomes C6H12O6, which is of course the formula I showed you at the beginning. It is the formula of glucose.